for extra work. Again, this problem is in the Schoology notes. The solutions are not. So we will go through that because of class time at a maximum. Here's the situation. It's similar again to the one we did in class. In this case, we have a rectangle inscribed under one arch of the sine curve. What is the largest area the rectangle can have? I construct a nice little sine wave. Now, why did I put the rectangle here? To me, it's the easiest because I'm going from 0 to pi. The nice thing, though, is sine curves are symmetrical. Rectangles are symmetrical. I could have drawn it here. I could have drawn it there. I could have drawn it all the way over here. This was just the easiest one to make. Now I am looking to make the largest rectangle, so I want to maximize the area of the rectangle. So inside this is some dimensions. This point here I labeled as A, an unknown measure. But because rectangles, and again sine waves, are symmetrical, this distance of A is exactly the same as this distance of A here. Since this is 0, since this is pi, it would stand to reason that this would be located at pi minus A. That would make the width of this the difference between these two. For example, if this is at 3 and this is at 5, the distance is 5 minus 3, so that's what I did here. I subtracted them. That is a width of 2 pi. Now the height of this rectangle. The height of the rectangle is unknown. Of course, it is the same thing as the height over here. It is a rectangle. And like the problem we did before in class, this height of B hits the sine wave at the exact same value. So all I have to do is figure out at this value what is the height of B by using the sine wave. And that's what I did here. B is equal to the sine at this point, pi minus A. Now that is the subtraction formula, which means if I do the sine subtraction formula, sine of the first, cosine of the second, minus the cosine of the first, the sine of the second, I get a couple nice things. One, this is 0, so that wipes this whole thing out. This is -1, combined with that negative, makes just sine A. So B, the height, is the sine of A. Now if I would have thought about that for a second, I mentioned earlier that this height is the same as that height, which means instead of using this point, I could have just used this point and found out the height to be sine A. But as we move on, I have my width, pi minus 2A. I have my height, the sine of A. So I am again maximizing area. Here's the area formula as a 2 variable. I just found out what B was. So now this is the equation I'm going to take the derivative of, and I'm going to find out where the maximum happens. Product rule. First, derivative second, plus the second, derivative of the first. Cleans up to this equation. Now I have to solve this for 0. That's awful complicated for everyone. So I'm going to use my graphing calculator. I am not going to take the derivative of this. I am just graphing this derivative to see where the horizontal or undefined values are. One thing I do want to keep in mind, on my window, because they're trig functions, they go on forever, I drew my rectangle between 0 and pi. So those are my limits. I am just going to look between 0 and pi. And what I have located down here is a little bit of sketch what I have on my calculator. I use the calc menu or the math menu on the TI-89 to find these locations by asking for the zeros, and these are the 2 values I got. Now remember, this is the derivative graph. That means if this is positive answers and these are negative answers, that means in the real graph this is a positive slope and this is a negative slope. And positive to negative makes that a maximum. Here I have a negative slope going to positive slope, which means this is a minimum. This is the value I want. Explained? Since the derivative at a is greater than 0 before that x value, and it's less than 0 after that x value, this has to make it a maximum. Now, I'm going to use this value. Again, I could check endpoints. If a is 0, it is not going to work as a value, because if a is 0, it makes pi times 0. That doesn't make sense. If I let a be pi, then I'm going to get negative pi, which doesn't make any sense, along with the sine of pi, which is 0. So those are my two minimums. This is my maximum. Going back to my values, I know that my width was equal to, get that off the screen. I have a value of width as pi minus 2a. I found a to be that value. There is my width. My length is the sine of a. Took the sine of that value. There's my length or height. Rectangle, width times length times height, however you want to describe it. There is my area. That will be the maximum area I can fit. Now that's not a lot of area, but remember, the sine wave only goes up to 1 as a height, so that's pretty squeezed. So there is example 2. I will be putting another example up. Please make sure you go through these. It is in your best interest to look at these values. Thank you.